Chapter 3, Intelligence. Data underpins everything. Quote, perfect is the enemy of good, unquote. Voltaire. Quote, if you come to the end of your transformation and your data isn't clean, you haven't transformed, unquote. Elouise Epstein. As we learned from the U.S. Secret Service, the key is to use intelligence to mitigate risk before it even materializes. However, to create intelligence, we need good, actionable data. This can be a challenge in a world that is creating vast amounts of data noise. Finding ways to cut through the noise and make data relevant can facilitate improved understanding and situational awareness. My goal here is to illustrate a very simple way to track and govern data and its role in controlling algorithms. This is the same skill buildup that we need to do with third-party data. The data value chain. I loathe it when consultants create arbitrary frameworks to convey simple concepts. However, when it comes to data and analytics, it is useful to illustrate the journey from data to intelligence. This provides a way to understand the process and point out the differences between data and intelligence. What is data? It seems like every day I read about how important data is and how we need to have a data-driven culture and intertwine data into business. That all sounds great on a PowerPoint slide, but it's quintessential consultant jargon, which I too am guilty of perpetuating. We need to move past these platitudes. Instead of talking about being data-driven, we need to say, where do I get the data I need? How do I make it usable? And most importantly, what can I do with it? In our future supply chain design, the crucial question is, how do we acquire, maintain, and refresh data from all the third parties we interact with? It's also deeply important that we understand what we mean when we talk about data. Is it financial numbers on a spreadsheet? Is it an Excel file extracted from a system? Is it the data sitting in an ERP system? The answer is, it's all of that and much more. Social sciences professor, researcher, and author Rob Kitchen defines data as, quote, the raw material produced by abstracting the world into categories, measures, and other representational forms. Numbers, characters, symbols, images, sounds, electromagnetic waves, bits that continue the building blocks from which information and knowledge are created, unquote. In short, everything is data. Whatever room you're in, there is data surrounding you. You are walking data, and every digital device you have, especially your phone, is a data beacon, leaving digital traces everywhere you go. If by chance you're reading this on a plane or train, or perhaps on your next plane or train trip, take a moment and look around. What data do you see? How many people are there? What's the gender breakdown? Can you make assumptions about age? What digital devices do you see? Can you see what people are doing on their devices? How are people dressed? And are there any commonalities such as the number of sweaters, jackets, hats, earrings, and so on? How many people are visibly sick? Let's hope you're not sitting next to them. Is anybody reading a physical book? Are there any markers that suggest people's origin or destination? How many people are carrying single-use plastic? If you formally collected this data, what could you do with it? If I asked you to sell a piece of software to these people, who would you start with and why? What about risk? Do you see any overt risks? Who on the trip is using the most carbon? Visualization, the limitations of dashboards. A client recently told me they had 430,000 contracts stored in their contract management system. I applauded the fact that they had that many documents and they knew where they were located. A fair number of my clients don't have a handle on where their contracts are. Then I waited for an awkward amount of time for the client to expound on what juicy insights they had found from all those contracts. When it was clear that no more information would be forthcoming, I moved on. Somewhere my client has a dashboard counting all of the contracts, showing the basic metadata. This is a good example of visualizing data. Visualizations allow me to see what data I have, but they do nothing to tell me how that data influences my operations or what I could be doing differently. And to get the data out of a dashboard to influence business decisions takes multiple steps. What I wanted this person to do was give me information about what's in those contracts. How many are active? How many different suppliers? What are the contract clause variations? And how many are up for renewal? the basics. I'm still very curious about the answers to those questions. One need not be a data scientist or understand advanced math to get these answers. You can be like me and have an unending curiosity for exploring data. My client was simply doing what was required, collecting and storing documents. That is not digital. To be digital would be to rip through those documents with an insatiable thirst to know what lies within. I still want to know what's in them. It would be looking at those documents and transforming them into something relevant. That data tells a whole story about my clients, suppliers, and ways of working. The fact that I know that there are 430,000 documents sitting alone in a contract management system just begging to be explored is something I can't let go. To get at this information, we need to use more sophisticated analytical modeling. Analytics, but what if I'm terrible at math? Whenever I turn around, somebody tells me we need to do real-time analytics or some equivalent. I barely passed high school algebra and somehow stumbled through college algebra, where I put probability theory to the test by guessing most of my answers. Then I studied history in graduate school, where I was able to sidestep statistics by studying 2 foreign languages, Spanish and German, but I digress. How is it that I can do the analytics that everyone keeps telling me about when I don't know the difference between a sine and a quadratic equation? Interestingly, and somewhat relatedly, I have become fascinated with Bayesian statistical theory, which is a theory for determining probability based on prior knowledge. It is used in all manner of practical applications, including artificial intelligence, bioinformatics, courtrooms, and war. It was a war example where the theory caught my attention. As someone who studies war extensively, I was immediately intrigued to learn that Bayesian statistical theory has a long and storied series of applications in modern war. Pioneering mathematical genius Alan Turing used it to reduce the number of probabilities while cracking the German Enigma encryption machine. This was utterly compelling and has led me down many rabbit holes researching how Turing cracked the code. Post-World War II, the U.S. military has used this theory to find a missing nuclear submarine, a lost nuclear bomb off the coast of Spain, and to help in Coast Guard search and rescue operations. As soon as I found a thread of personal interest, I became much more comfortable swimming in the mathematics that normally eludes me. Fortunately, tools now do sophisticated analytics without me having to type a formula. Most of the analytics tools on the market can walk a user through the creation and application of analytical models. All you have to do is upload your data and explore the available analyses. There are even features in these tools that will surface insights you didn't even know to ask of your data. Going back to the 430,000 contracts, we could use these same analytical tools to interrogate the contents. We could surface variations in payment terms, risk clauses, or simply cancellation terms. We could analyze the time spent on contract creation and look for ways to reduce inefficiencies. We could also combine spend and performance data to analyze how the suppliers we pay the most are performing and correlate that to commonalities or differences in their contracts. Turning data into intelligence. In the summer of 2022, I took 4 weeks off to write this book. 2 weeks into my writing sequester, I realized I was spending more time watching YouTube video clips and binging on Netflix instead of writing. So I decided to start with a simple experiment. I would try to read for 30 minutes, write for 30 minutes, and watch YouTube clips related to the book for 30 minutes each day. I tracked this as a way of keeping myself accountable and to measure my progress. I am very driven by my own individual performance. I am constantly pushing myself beyond my limits, whether it's having an absurd travel schedule or doing 16 Zoom calls in a day or writing 5 books in 10 years. This is book 3. It wasn't long before I realized I was interested in tracking other elements of my life, so I added a 4th dimension, self-care. The goal was to see if I was doing something each day to look after myself. But self-care quickly turned out to be highly variable. One day I was watching the animated series Harley Quinn, and the next it was taking a nap. So I added 2 fields, one to track whether I did self-care, and the other to describe what I did if I met the objective. Over time, I started to become very curious about what else I could be tracking. I had 5 fields: date, writing, reading, video, self-care description. But I also have an Apple Watch. And I was trying to close the 3 rings, move, exercise, and stand each day as well. Here was a device that was generating data about my physical performance and inducing different behavior. I was, and am, fixated on achieving the daily, weekly, monthly goals. This got me thinking about what would happen if I extended my data model with data from my Apple Watch. One would think that all you'd have to do is click a button on the watch and it would send an export of your watch data to a spreadsheet that could be imported. Not the case. I went down an obsessive path to figure out how to export the data from my watch, which requires using the Health app on my iPhone. Unfortunately, the export came out not in a CSV file, but XML. So I had to find an app to do XML to CSV exports. I used a tool called Health Export, which converted the health data to a CSV file that I could incorporate into my spreadsheet. Once I managed to import the data, I looked to see how I could streamline and automate this process. This is what it means to be digital. Digital is messy. When tools don't work, you need to poke, prod, and experiment to figure out how to get the data and/or functionality you want. Not that the individual choices matter too much, but these are the elements of data governance that have to be reconciled. And these are the trade-offs and elements that every leader has to understand. This is what it means to get your hands dirty with data. For the non-quants, this is a good way to enter the world of data. This whole exercise provides a useful anecdote on the data value chain. I started capturing the data. Then I visualized it so I could see what was happening. Then I analyzed the trends to inform what improvements I could or should make. However, it was only when I used these insights to create the strategy that changed my behavior that the data became intelligence. Needlessly overcomplicating third-party data governance. My intelligence example above brought forth a series of data governance problems. If data is an everyone opportunity, then data governance is an everyone responsibility. For the data tracking example above, here are some of the questions I had to wrestle with. What do I do if I write for 25 minutes but not 30? My solution, if I go over 27 minutes, I round up. Otherwise, I don't count the effort. What if I forget to set my timer while reading? My solution, I will equate 1 page read to 1 minute reading. What do I do if I go a couple days without inputting the data and I can't remember if I did something or not? My solution is to default assign no across the board. At a certain point, I needed to make clear decisions so that I could make effective use of the data. This was a hard process, and to this day, I find myself debating whether I need to revisit the rules. Now imagine supplier records. Think about all the various data elements for one company: legal name, headquarters address, subsidiaries, parent company, ownership structure, leadership, banking information, satellite offices, plant locations, warehouses, and so on. This doesn't include any risk or ESG data. We can quickly have hundreds, if not thousands, of fields for a single supplier. How do we govern this data? This is where leaders need to lead and get their hands dirty. Leaving data governance to random teams of volunteers, or worse, middle managers, will ensure the failure of data governance. Except in rare cases, middle managers will overly complicate the data governance process by trying to allow for every possible permutation. Here, activity outweighs productivity. In an enterprise with many ERPs, getting data governance correct is a red herring. You need to get it good enough instead of perfect. This means making clear and concise decisions and moving on. For example, in my question about writing 25 minutes versus 30 minutes, I just need to choose. I have seen the corporate world take a simple decision like that and create the most convoluted solution. To witness spectacular complexity and failure of data governance, simply look at any company's benefits tracking. Our inability to effectively measure and track benefits is one of the great embarrassments of our profession. There is little benefit in having the perfect solution. Part of operating in a digital mindset is to work as if everything is continually evolving versus do it once and change it never. Today's data governance decisions should be continually revisited, improved, and changed. In my example above, I started with 3 simple measures, and gradually I extended my data model. Each time I did this, it brought new governance questions and choices. This did not derail my progress or even slow it down. Just like citing any research, I created data definitions, what fields I'm tracking, where the data is coming from, and of course, the answers to the questions that came up. There is no reason not to document the provenance of our data so people can understand how and what choices were made. It's no different than a research paper or a business case. This is how we start to build good data hygiene practices. When we make data interesting and relevant to everyone is when we start to solve some of these problems. Thus, we need to quit holding out for a hero or a magic button. Someone else is not going to fix it, and no tool will miraculously fix our bad data. If the entire business does not embrace governance, then we will perpetually have bad data. We all need to roll up our sleeves, embrace the pain, and get to work. It's like making a meal. If everyone participates in the preparing, cooking, and eating it, then everyone had better participate in the cleanup. Data governance is hard. Sidebar: Elouise's data for tracking. I created my simple tracking sheet in Airtable, a fancy online spreadsheet that automatically brings the different columns to life with imagery and extensive use of color. This made the data readily accessible and engaging to me, instantly appealing, as I don't respond well to numbers on spreadsheets, but anybody can do the same exercise in Excel or any other spreadsheet software. The goal was to make the data easy to track. Additionally, for ease of use, my entries are yes or no. However, you quickly realize that to do any useful analysis, the yeses and nos have to be converted to ones and zeros. I chose to use the yes-no paradigm because it's more pleasing to me, and I'm happy to do the conversion as a later activity. Again, these are the types of trade-offs and decisions that leaders must stick their nose into. Otherwise, data governance teams quickly find themselves creating overcomplicated workaround rules that don't help. Hacking intelligence, 5 takeaways. 1. Use intelligence to mitigate risk before it materializes. 2. Digital is messy. Embrace it. 3. Data governance is an everyone opportunity. 4. Understand the data value chain. 5. Overcome your fears of not understanding analytics.